Hello everyone, welcome back to Ezugo STEM Hub. Today we have a common physics question. How can you calculate the energy in a photon when its wavelength is given? Let's do this step by step. Okay, this is the question. Calculate the energy of a photon of wavelength 6 times 10 raised to the power minus 7 meters. We are given Planck's constant to be 6.6 times 10 raised to the power minus 34 joules second, and the speed of light to be 3 times 10 raised to the power 8 meter per second. So there's an equation that relates energy, Planck's constant, and frequency. And that equation says that the energy is equal to the Planck's constant times the frequency. But if you can recall during our wave classes, there's a formula that relates both speed, frequency, and wavelength. And that formula says that the speed is equal to the frequency times the wavelength, right? Now, I can make the frequency the subject of the formula because the equation requires the frequency, right? But the frequency was not given in the question. So if I make frequency the subject of the formula, I will have V over lambda. That means the speed over the wavelength. For this particular question, the speed is denoted by C. So F is equals to C over lambda. So what I'll do now is to plug this into this equation. What do I mean by plugging this into this equation? Where there's frequency in this equation, I'll replace it with C over lambda. So this will give me E is equals to HC over lambda. Before we continue solving this question, because we are almost done with the question, this question is the number 8 question for the NECO 2025 examination. Please, if this has been helpful to you thus far, do not forget to hit the like button, subscribe, and share to your classmates. And do not forget that every week we'll be having classes on WAEC, NECO, JAMB, IGCSE, and Olympiad Maths. Get ready as we dive into the words of science. Okay, back to the question. Now, we need to plug in each of these parameters in this equation. So I'll have that E is equals to, what's my Planck's constant? 6.6 times 10 raised to the minus 34 joules second, right? I'll give you 6.6 times 10 raised to the power minus 34. Then my speed of light is 3 times 10 raised to the power 8. Then what's my wavelength? My wavelength for this particular question is 6 times 10 raised to the power minus 7 meters. So I have 6 times 10 raised to the power minus 7 meters. So therefore my energy would be, okay, let me punch that in the calculator so that I can get it. So I'll have 6.6 times 10 to the power of minus 34 multiplied by 3 times 10 to the power of 8 divided by 6 times 10 to the power of minus 7. So I'm getting my energy to be 3.3 times 10 raised to the power minus 19 joules. So therefore, for this particular question, the energy in the photon is 3.3 times 10 raised to the power minus 19 joules. Please do not forget to like, to share, and to subscribe. Catch you in the next video.